So let us start today's session. In our previous session, we have in parallel out these things we have seen in our previous session, and we have learned how to design them using our concatenation operators as well as shift operators. Using concatenation operator, how to design your right shift operation, left shift operation, and using normal shift operators, how to perform right shift operation, left shift operation. This and all things we already know and we have seen in our previous sessions. I hope there is no doubt or no queries in our previous session. Now, in this particular session, we will start with the design of parallel in serial out and parallel in parallel out. So let us try to design this parallel in serial out. Okay, so this particular design parallel in serial out is going to look like this, where you are going to have clock, a reset signal, and you're going to have one parallel input of 4 bits width, and you're going to have one serial output which is of only 1 bit width. Okay, and here you're going to have one more signal which is known as load. So if this signal load is equal to 1, then you are going to load the data parallelly to this PISO, and if this load is equal to 0, then you are going to get your serial data output from this PISO. That is what we are going to try to design it. Okay, and again you can do the design using either shift operators. You can either perform the design using the shift operators, or you can either perform the design using concatenation operators. You can perform anything. You can either use shift operators or you can either use concatenation operator for performing this particular design. Okay, now let us try to design this. Let us open the tool and let us try to design. So let me create the file here. Create file. Next, create file PISO and press OK and press finish and just click OK and press yes. So PISO file will be created. Let us wait for the creation of that particular file PISO. Yes, so PISO file has been created. Let us write down the code for this PISO. So this PISO will have inputs as clock and reset, and parallel input are our inputs. So let me declare them. Input as clock and reset, and one more input is of 4 bit width. We are going to design a 4 bit PISO, so I'm going to declare a 4 bit input 3 down to 0 p underscore in, that is a parallel input, and I'm going to get a serial output s underscore out. Okay, so this is my inputs and outputs of this PISO, and I'm going to declare a temporary register 3 down to 0 temp, and within an always begin in block, always at the rate passage of clock begin. If I apply my reset signal, if I apply this particular reset signal, then I'm going to make all the contents to 0, 4 tick minus 0 0 0. Else what I'm going to do is I'm going to check for the load signal. So I'm going to check for the load signal. If my load is equal to 1, if my load is equal to 1, then temp is equal to p underscore n. That is, I'm loading the parallel data into my temporary register. Else if my load is equal to 0, then I should perform the shifting operation. Now, in the case of your PISO, how you are going to perform the shifting operation? So this is your temp, and this temp, initially you are going to load your data. What is your data? Let's say 1011. Now if you want to perform the shifting operation, then what happens? Let's say if you are going to perform the right shift operation, then what is going to happen? This one will be shifted over here, this will be shifted over here, and this will be shifted over here, and at the MSB you are going to insert 0. Okay, and again what is going to happen? This 0 0 1 and 0. Okay, so you can see the MSB is filled with zeros. The MSB is filled with zeros. This is 3 2 1 0, and the remaining bits are nothing but the current bit. The current bit is nothing but previous 3 2 and 1th position. Okay, the right shift already we have seen in our yesterday's session also. So how to perform this shift operation? I'm going to write down begin temp is equal to concatenation of 0 comma temp of 3 colon 1. Okay, so this is what I am going to do, and followed by end. This is my right shift operation which I'm going to follow. If my load is equal to 0, I'm going to follow this particular operation and end. Okay, Now this is my temp concatenation. Okay, so here if you write down simply 0, then it will consider it as 32-bit digit. So you should be very careful in this particular thing. You should write down explicitly one tick binary 0. Then it will consider it as a single bit 0. Okay, yes, that's all. And this is my code for my PISO. Let me save this and let us write down the test bench for this. So how to create the test bench we already know. Let me create the test bench for this. So this is my test bench file which I have created. Let me open this file. So in this file, let us write down. First of all, we need to declare our inputs and outputs: rich, clock, reset, and load signal also we are going to have, and wire, and one more signal is rich 3 down to 0, p underscore in, and wire s underscore out. These are my inputs and outputs of my PISO. Now I'm going to initialize them. How to initialize? First of all, I need to instantiate my design. How to instantiate? Design name followed by instance name, clock comma reset comma load comma p underscore in comma s underscore out. So these are my inputs and outputs which I have instantiated my design. Now what I'm going to do is initialize my inputs. How to initialize? Initial begin clock comma reset comma load comma p underscore in is equal to 0 and followed by end. So I've initialized my design and I will generate the clock. Always hash 5 clock is equal to not of clock, and this clock comma load comma clock comma reset comma load comma p underscore in. Okay, and I've generated my clock, and within an initial beginning block I'm going to drive my inputs. How to drive my inputs? First of all, I'm going to apply my reset signal, and after 10 time minutes I'm going to make it as 0. Next, what I'm going to do is I'm going to apply my input p underscore in. This is a parallel input, so I'm going to apply my parallel input as, let's say, 1101. This is my parallel input which I'm going to give, and also I'm going to give my load is equal to 1 tick binary 1. So load signal is equal to 1 and parallel input is I have given 1101. Okay, now what I'm going to do is, with some delay, let's say after 40 nanoseconds, because I have okay, let's say after 20 nanoseconds I will make my load signal is equal to 0. So the data will be shifted for 2 times. Load is equal to 1 tick binary 0. Okay, and followed by end. So this is what I have written here inside my code. Now let us check how it is going to work. Let me save this first and let me make sure that it is set as stop. So this I will right click and click on set as stop. Let us check. So this is my s underscore out which I'm going to get, and in my design I should collect my output. So nowhere I'm collecting my output, right? So in design what I'm going to write down is s underscore out is equal to temp of 0. So I should collect my output also, right? Now let me save this one more time and let us run this. It is s underscore out. Save and relaunch this one more time. Let us check it in the waveform, how we are going to get our data. Let me maximize this. See, so this was our parallel input, which is nothing but 1101, and what is that we are getting serially out is 1 0 1 and 1. Okay, you can see, right? So 1 0 1 and 1. So this is how we are going to check whether our design is working correctly or not. Okay, so this is the working of our PISO, parallel in and serial out. Now next, after this parallel in serial out, we are going to have one more register which is nothing but our parallel in parallel out. So let us try to write down that particular code. So how to write that? First of all, let me create the file, create design sources, create file, PIPO, and press OK and finish, and press OK here, and yes. So let us write down the PIPO code where I have created. It is getting updated. Yeah. So the PIPO code open the file, and here we will write down input clock comma reset comma input 3 down to 0 parallel in and output reg 3 down to 0 parallel underscore out. So these are my inputs and outputs for my design. Now I am going to declare a temporary register reg 3 down to 0 temp. Now, so first of all, let us write down the reset logic here. Always at the rate passage of clock. If I'm going to apply my reset signal, then begin. What I'm going to do is temp is equal to 4 tick binary zeros. End. Else if I should have one more signal which is known as load. So if my load is equal to 0, I'm going to load my data into the PIPO, and if my load is equal to 0, then I'm going to get the data out of this FIFO. Okay. Else if load, then my temp is equal to P underscore in. Else if load is equal to 0, then my P underscore out is equal to temp. So this is how I'm going to write down, and followed by end. And always at the rate passage of clock, begin and end. So this is how we are going to see this, and yeah, let me save this file and let us write down the test bench for this PIPO, and let us create a file. The file name is PIPO underscore TB, and press OK and finish. So a file will be created and press yes. Now, so I've created my test bench. So what I'm going to do is, first of all, I need to instance, I will declare the variables reg clock comma reset comma load comma load semicolon reg 3 down to 0 p underscore in is my input, and wire 3 down to 0 p underscore out. So these are my inputs and outputs which I have declared, and let me instantiate my design clock comma reset comma p underscore in comma clock comma reset comma load comma p underscore in comma p underscore out. So these are my inputs and outputs I have instantiated, and within an initial begin block I'm going to initialize them clock comma reset comma load comma p underscore in comma just that's it is equal to 0. I've initialized them, and next I'm going to generate my clock. How to generate the clock? Always hash 5 clock is equal to not of clock. I've generated my clock, and within an initial begin block I'm going to first of all apply my reset signal, and then after some time I'm going to remove my reset signal, and next I'm going to provide my input p underscore in is equal to 4 tick binary 1110, and my load signal is also equal to 1, and after let's say 30 time unit I'm going to apply my input, sorry, I'm going to make my load signal is equal to 0 and followed by end. So this is my test bench code which I've written, and let me save this and let us check what are we getting. Let me relaunch it, and first of all I should make it as a top, set as top. Yes, so whatever the inputs which we are giving here, those outputs we are getting at the output, that's it. So we are giving E and we are getting the output as E only. Okay, so this is nothing but my parallel in parallel out, and whenever your load is equal to 0, then only you are going to get your output, or else you are not getting your output unless and until your load is equal to 0. Okay, so this is how we are going to work with our parallel in parallel out. So with this we have completed all the registers, all the shift registers, serial in, serial out, serial in, parallel out, serial in, parallel in, serial out, and parallel in, parallel out. Now in the next session we will start with the discussion of universal shift register, and we are going to see how to design that particular universal shift register, and after that we will start with the discussion of counters. Yes. So that's all about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.